I realized that this is a kind of an interesting position for me to be in, to talk about sort of something that's new to people who might know already some of this stuff. So feel free to interrupt and ask questions during the presentation. So I want to tell you a little bit about something that we've been calling augmented social cognition at PARC for a little while. And this is joint work with two of my interns, Aniket Kaur, who's at UCLA, Todd Mikovits at UC Boulder, and Brian Pendleton, who's a programmer in our lab, and Bawan Su, who is a recent hire in our group. So first, I wanted to sort of give you a little bit of a retrospective on the kind of work that I've been doing. I actually started out in the area of graphics and information visualization many years ago, and for which I'm probably the most well-known for some work that we call sort of visual sense-making. That is, making sense of information through visualization. And I'll just show you very quickly some pictures of the kinds of things that we've actually done. So for example, in '98, I published in the Chi Proceedings some visualizations of whole websites and their traffic patterns. So you could actually see where the interest or attention people are paying in these websites. And then that actually led to some work in which was actually the topic of my PhD thesis, which is the visualization spreadsheet. And that is about representing whole data sets, like, for example, the traffic pattern of an entire website, and put them into a spreadsheet and represent it graphically. And you can actually do subtractions and additions between the traffic and actually do computation around the traffic patterns that exist on the website. And then I was hired at PARC about 10 years ago. And ever since then, I've been working on a concept called information scent, which is a series of underlying technology that is used to do things like, for example, simulate the usage of a website and actually identify usability problems. And that was actually embodied in a almost product, a product that never made it to the market called Bloodhound, simulating how people actually sniff through the website and follow the information cues to the information they're interested in. And then I also worked on a system called Lumberjack, which is a user log analysis, a server log analysis tool that, in addition to actually doing the analysis, he also did this extra clustering step that actually figured out what users must be paying attention to. So it actually can tell you things like, for example, 30% of your users are actually interested in downloading drivers, and 20% of your users are going into the support site. And then from there, I actually worked on a bunch of search and foraging tools. Things like, for example, published in the ACM Tokai journal was this idea called Central that I worked on with a student of mine named Chris Olston, who's now an assistant professor at CMU. And the idea was to use this information set modeling method to actually highlight URLs or links that the system is predicting that the user is likely to want to follow. And it turns out that you can speed people up by about 50% when you do these kind of predictive algorithms.
So this is based on more than just the overall click rate on a link?
That's right. It's
actually
actually
on the profile of the user?
based on the profile of the user and the linkage and textual analysis of the website. Yeah. And then I worked on something called the Send Index, which is about how do you take something like the back of the book index or some sort of hierarchical ontology. Oh, what happened? Oh, that's not cool.
It had to be something with it.
Yeah, stupid. I apologize for that. So, which is about using ontology information to see if you can actually enhance the way people can browse through a book. And then from there, I also worked on something called Send Highlight, which is about using these kinds of computations to figure out if you can actually predict where people want to pay attention to in pieces of text and actually highlight keywords or phrases in which people might want to pay attention to. So you can pre-highlight. Imagine getting a textbook that's already pre-highlighted with all the interesting bits that you might want to pay attention to. And that's what Send Highlighting did.
So,
And
so again, is this clustering So is it the same for everyone that approaches this?
No, it's again based upon a combination of user profiles that you've given to the system, as well as a set of search keywords. So it's a combination of those that actually highlights the places that you might want to pay attention to. And then, of course, there's evaluation behind all this search tool and foraging tools that I worked on. One of them was actually using eye trackers to figure out if people were indeed paying attention to these highlighted areas. And on top of all this,
I'm sorry, was that before you highlighted it or after?
Yeah,
And so was
that's
that
like
evaluated on the highlighted?
we evaluated both
before and after.
as well as alternative methods of highlighting, where you only highlight the keywords as opposed to sentences and things like that. And so this is actually to be published this summer. And the eye tracking analysis of this kind of stuff obviously is extremely challenging. But we have a whole laboratory set up for this kind of analysis. And then finally, I've actually also worked on some personalized search, which I do not have time to talk about, and it's not yet being published anyways. So all this is to say, I've spent 6 minutes to tell you a little bit about history, which I'm not expecting you to know all the detail of the things I talked about, but is to say that this is basically the environment in which I've been working in for a long time, which is part of it, obviously. This is my actual office at PARC, and as you can see, I have 6 screens and I have a funky keyboard. And what this is all about is saying that I've been focused for the last several years, 10 years or so, all on this sort of personal computing, you and the desktop kind of environment, right? And one of the things that we do at PARC is to say, well, we should take this to the max. That is, how many of you have been happy with working in front of the airline tray table? Right? I mean, that's the size of this laptop, right? So we said, screw that, right? Let's actually replicate what it would really be like working in front of a desk that's 6 feet wide. And that's why many of us at PARC actually have 6 high-resolution screens in front of us, and noticing to see what that's like. So the history of my research has been in this area of sort of desktop computing and how do you enhance people's productivity and et cetera. But then after all these years, I kind of had this realization, and I really think it's somewhat of a stupid realization, and it comes no surprise to many of you that humans are indeed social animals, and we want to connect with other people. One of the reasons why I'm here and you're willing to listen to me, I'm extremely grateful, is because you want to find out what I'm like and what my research is about, and that's a social act, actually, right? And so from a superficial level, you can just say humans are social, but I actually recently had a very personal experience with this. But for one thing, it's not just me kind of slowly have discovered this, but the web's kind of started slowly discover this, and some people have started calling this thing Web 2.0 or the social web or whatnot. And I had a personal experience recently where this really hit home, why this has really changed and the way people think about the web. I just got married in October, and 2 weeks before I got married, my future father-in-law, now my father-in-law, was diagnosed with pancreatic cancer. And it was one of those things that really changes your entire perspective on priority in life and everything. And the day before I was due to give this exact same talk at a place called HCIC Consortium, I got an email through my system, and from this guy named Brad, and he sent me this email. It says, "Hey Ed, I'm a fellow Delicious user and noticed that you bookmark a lot of pancreatic cancer stuff. I'm at home with my dad, who was diagnosed a little over a year ago and is now at the tail end of things. I've learned a lot through his treatment about what's out there. I don't know if it's something you or your family has, but just wanted to drop you an email and be well." And I was sitting literally in the middle of this workshop, and tears just started running down my face because this was such an emotional experience for me. That someone else who was having this exact same problem actually sent me email, took time out of his busy schedule, dealing with his father's illness, to send me email and connect with me in this very personal way. And we started a conversation through his blog as well as through email. And it turns out that he has a really interesting blog on the web chronicling his experience of dealing with this disease, his father's disease. And I'm sad to actually say that Brad's dad passed away about 7 days after he sent this email. And so this whole experience really reinforced for me what Web 2.0 or the social web has really been able to connect people through blogs, through various different kinds of communication. And so what is really Web 2.0 about? It's really somehow something about the many semi-new mechanisms and services that seems to be out there. And from a research point of view, what I really want to talk about here is that these Web 2.0 mechanisms can be studied and characterized. And so let me try a little bit on this. Okay, so on the one end of this collaboration spectrum, you have something that's more lightweight. So lightweight social processes are things like, for example, counting votes. So it's a way to sort of identify the faddishness of information. It's a way to maybe increase the signal-to-noise ratio of the information that you personally receive. So an example of something like this is like dig.com, or the most bookmarked item on Delicious, or if you have read the book Wisdom of the Crowd, Jack Sorowitsky, I'm probably going to pronounce that name incorrectly, but the classic example of this actually was estimating the weight of an ox in a room of people. It turns out that the room of people who, if you take the average of the guess, was better than an expert's guess. And that was something that was a little bit surprising. And when you think about it, really the truth value of a stock, like in the stock market, is also kind of a wisdom of the crowd kind of effect going on. It's really an electronic market. And I'm told actually within Google, there's actually this electronic market for ideas, right? There's another instantiation of this. And then to some extent, really PageRank or hub and authority algorithm in general is also a kind of this lightweight social process where linking one page to another page is really a vote, and therefore it's kind of just a vote counting mechanism for figuring out what's important, what's not important. In the middle of the spectrum, you have systems that actually evolve information structures that can be used to actually organize that information. So for example, Delicious with its social tagging, Flickr was the tags and the photographs, and they actually have algorithms that find the most interesting photographs in that tagging relationship that's established by the users. YouTube, Friendster actually create friendship relationships and social networking things, right? At the high end of the collaboration spectrum, you have things like wikis. So Wikipedia certainly is the most well-known example here. What's going on there is that you have groups that actually utilize systems to make sense and share complex topics and materials. And not only that, they actually have, users actually have discussions with each other. So very heavyweight kind of collaboration. And they actually also use sort of some of the lighter weight mechanisms, like for example, the social status or karma points, to actually entice people to participate as well as a way to sort of counting votes and sort of have some information faddishness identification along with it as well. One of the interesting things here is that there's a system called Lostpedia. How many of you have actually watched the show called Lost? You probably are all too busy to actually watch this. But, well, at least saying that it's too complicated, you probably know something about this show. So Lost is this show that I've actually never watched, but it's apparently this show about mysteries on TV. And there's a group of people who have banded together and used Wikimedia as a way to figure out all the puzzles in this show. And some of the puzzles are so complex such that they span multiple continents. So for example, there was one case where a particular item was hidden in the Sydney store window, and the cue was given off in the show itself, and within 24 hours, people through collaboration mechanisms on the net actually found the item in that storefront in Sydney through a bunch of little cues that needed to be solved. And so this is the kind of collaboration that people are actually carrying out using these kinds of technology. So if you think about these different kinds of social processes, going from very lightweight to heavyweight processes, you have PageRank and Dig on the one hand, Flickr, IBM Dog Year, which is a social tagging system for the enterprise, and then you have Slashdot and Wikipedia, which are a very heavyweight collaboration on the other end. Okay, so it turns out that this little axis in which you can lie this lightweight collaboration to very heavyweight collaboration also correspond to many different other kinds of properties. Things like, for example, as you go toward heavier weight collaboration, you need more interactivity between the user. You have more computer support. There's more social network connectivity that gets created. There's more explicit cooperation. But it turns out that there are also more potential for conflicts. And the more you go toward Wikipedia, you're really making sense of something as opposed to just searching or browsing. Right? So all of these things kind of are rolled into this one axis. And it turns out that in order to really understand what's going on here, you need to bring in research from many different fields. So for example, on the voting system side, you have the understanding of the microeconomics, the behavioral economics of foraging and search, work that has been done by people like Bernardo Huberman, Lada Adimic, et cetera. And then you have the wisdom of the crowd kinds of theories and things that are being built there. And then you have actually things from the School of Information Sciences, like concepts like, for example, information cascades, which is about the idea of that a piece of information actually gets transmitted from person to person, sometimes without deliberation, right? So a misinformation can travel precisely because of the information cascade, because not each step is actually vetted, as an example, right? So in the middle of the spectrum, you have a lot of analysis that's needed for social networks. So for example, Ronald Burt's work at University of Chicago on this idea called structure holes is about the brokerage of information. What he found was that actually people who tend to brokerage between different groups, that is, you have a group of people who are interested in psychology, another group of people who are interested in computer science. The people who broker ideas between these two groups, those people actually turns out to be also the higher performing members of the organization. And he actually showed that your salary, that he studied at a big organization, and he actually showed that being in a brokerage position actually corresponds to the amount of salary that these managers received. Yes?
Is that a cause or an effect, do you think?
Oh, that's a very good question. I don't know. I haven't read all of Ronald Burt's work in this area, and so certainly he showed that there's a correlation, and he argued that it's a causal effect. But I think you should probably read his own work to make your own determination. My personal belief that it is a causal effect, but maybe it hasn't really been shown academically or scholarly yet. And then you also have, in the middle of this, a lot of kind of data mining mechanisms that's required. Things like, for example, information theory from Klaus Shannon or latent semantic indexing kinds of work that you actually need to, in order to figure out what kinds of information structures you can actually extract out of these kinds of either social networks or content with the linkages information that's there. And then at the far end of this spectrum, you have things that are more toward the sociology or more toward the information science analyses. Things like, for example, the understanding of conflict and coordination between people, invisible colleges of people who actually form. For example, Pamela Sandstrom's work has shown that if you look at linkage analysis of the content that are produced by people, you can actually see these little groups of people that didn't really talk to each other, but they actually are collaborating through knowledge artifacts. And then Peter Peroli has done some work in understanding interference effects from one person giving hints to another person, and when is it beneficial and when it's not beneficial. And then Gary Olson and Judy Olson at University of Michigan has done some work in collaboratories, which is laboratories that are spanned across geographical areas, and then they need to collaborate and be productive. What are features of these collaboratories that make them successful or not successful? And then Jack Carroll's work in collaborative problem solving also needs to be fed in to actually understand this space. And then there's sort of these kind of slightly fuzzier things that I'm not so sure how it really fits in. So things like, for example, why do flame wars happen? Clearly emotion play a role, but what's the understanding of emotion that we can use actually to model these processes and therefore, maybe filter out flame wars or something like that. So understanding of these kinds of things require inputs from all these different fields. So that's all by way of introduction to this idea of what I mean by augmented social cognition. So if you look up the definition of cognition in the dictionary, it is the ability to remember, think, and reason, the faculty of knowing. So social cognition, therefore, at least my usage of the term social cognition, is the ability of a group of people to remember, think, and reason, the construction of some sort of knowledge structure by a group. Okay, so this is not quite the same as in the branch of psychology that actually calls something social cognition, where they really mean cognitive processes, that is cognitive processes of the individual that's involved in social interaction. So that's part of this, but not the whole thing. Okay, so anyways, social cognition is really just the ability of a group of people to remember, think, and reason. And then finally, that leads to what I mean by augmented social cognition, which is some sort of enhancement or support by the systems, the ability of a group to remember, think, and reason. Okay, so that's what I mean by augmented social cognition. The system-supported construction of knowledge structures by a group. Okay, so to the extent, if I don't want to be pompous and say that this is a new field or anything like that, but to the extent that you believe that there's a new phenomenon going on the web about the way in which a group of people get together to think and remember and reason, then there's a need to actually go and understand and study how this process actually works. And at this point, I kind of want to quote John Tukey in saying that, well, what's the first step in solving any interesting problem is to get some paper and pencil, and you stop plotting the damn thing. Okay, and so this is not a direct quote, but John Tukey was a consultant at PARC for many years, and this is always the first advice he gives to people when they have questions about, how do I go and solve a problem? So let's get some paper and pencil. Well, in this day and age, we don't really use paper and pencil. We use the computer to count. So let's use the computer to count. Okay, so the first step in trying to understand this area is a bunch of characterization studies in augmented social cognition. And so we're going to start doing that by looking at Wikipedia and Delicious. And I'm gonna breeze through basically 3 conference paper submissions that we submitted this past summer, and so that you get a flavor of the kind of characterization study that we've been doing. So the first one is studying the increasing coordination costs in Wikipedia. This is joint work with Nikki Couture, Bawan Su, and Brian Pendleton. So we want to understand the coordination cost and how it is affecting the long-term viability of a collaboration information environment like Wikipedia. The data that we have is essentially the entire dump of Wikipedia as of July 2nd, 2006. It contained 56 million revisions, 4.7 million wiki pages, 2.4 million actual article pages, and about 800 gigabytes worth of information. Certainly smaller than the kind of data set that Google is already dealing with, but not a non-trivial data set, certainly. We believe this is the first plot of something like this for Wikipedia. So the first thing is that we define something called direct work. Direct work is any work or edits to the article pages that actually results in moving the article forward in some way. And that's what we mean by direct work. And you can see that starting from 2001, where it's essentially 95%, it has gradually decreased to something around 65% or 70%. And so there's direct work, that is edits going directly into the article pages, indeed is decreasing. Okay, so very good question. I'm going to get to that. So in terms of indirect work, there's actually a wide variety of indirect work. So for example, increasing amount of traffic on Wikipedia is people talking to people. Well, that's not exactly a surprise. So users actually discuss with each other about things like what should go into the article. Or sometimes they just have discussions on things, various different things. And it turns out that if you categorize those, starting in mid-2001, there's a little bit of people talking to people. And then getting to about July 2006 of about as high as 12% or so and right now probably between 8 and 10%, something like that.
There was a mechanism change at one point where they introduced a discussion page. How do you incorporate that?
Yeah, so that's basically back here when they really incorporated the discussion pages. So these are users talking to each other, and then you're really asking about also article discussions as well, and I'll show that in just a little bit. And then as you previously alluded, there's also a lot of procedural discussion that happens on Wikipedia about things like rules and policies about how this thing should be run. And it turns out that there indeed has been a corresponding increase in the amount of discussion about what the procedure should be, going from 0% to in mid-2001 to about 12% currently. Right? And then reverts, which you asked about, also has been increasing from 0% to about 6 or 7% in the last couple of years. Okay. And so if you take all those graphs and put it into what we call a stack graph, you get an overall sense of all the movements of the kinds of edits that are going into Wikipedia, where they're going. So for example, I apologize that I kind of lob off 0 because it's in order to actually show you what's really the trend that's going here. But it's very clear that you see this trend that the work going into article is decreasing. Correspondingly, there's been an increase in user talk, in maintenance, and in a lot of these other sort of procedural and indirect work.
What's an edit?
What's an edit?
Because you just correlated edit with work. So is
Right.
time somehow involved?
Well, time or the amount of edit that you're actually doing,
So
for
are you
example.
counting the number of bytes in an edit?
Yeah,
or-
so I'm going to get to that in a little bit in the next half of the talk. So I'll get to that a little bit. So in addition to understanding the coordination and conflict at the global level, we're also interested in conflict at the article level as well. So we want to understand how you could actually model conflict at the article level. And building that characterization can lead you to, for example, identify high conflict article and therefore maybe have intervention before it gets out of hand, or you could have a little social dashboard of showing people where the conflicts are so that they can actually put in their 2 cents, depending on. The point is that identification of article at that article level can be very, very useful. The trick we played here is to use this. It turns out that in Wikipedia, there's this thing also called, they also allow tagging. And some of the tags have special meaning. So for example, a tag called controversial actually tags an article as being controversial or not at that moment in time. And what we decided to do was to use this controversial tag in a somewhat novel way. If Article 1 and Article 2 both have 10 revisions, but Article 1 had 8 revisions in those 10 that have been marked controversial, that is, the controversial tag was applied to it while that revision was being made, and then we say that it has 8 controversial revisions. Whereas Article 2 only has 2, and then therefore we would say Article 1 is much more controversial than Article 2. Okay, so that's kind of the rough measure that we decided to use. So assuming that you kind of believe that there's a little bit of a ground truth for measuring how much conflict there is at the article level, can we actually identify what pages are actually in high conflict and why? So what we decided to do was compute a bunch of very easy to compute metrics and see if you can predict what articles are in conflict. And so some of these metrics are really easy to envision, like for example, number of revisions to the article, to the associated talk page of the article, to the page length. Maybe the longer pages are more controversial. Number of unique editors that has contributed their voice to the article. Maybe that has something to do with the amount of conflict there is. A big discussion has been around anonymous edits. Right? Do anonymous edits actually increase its conflict or not? That's another thing we looked at. So what we did was essentially use a support vector machine on all these different metrics and to try and predict how many controversial revisions that articles have. And this is we did a 5-fold cross validation. This is just one of those plots that we did, and you can see that. It's fairly correlated. Anyone want to venture a guess on what that upper right-hand corner dot is? wow, I've given this talk 3 times now. I can't believe people are just picking it right out. Indeed, that is George Bush. I actually thought it was going to be something like intelligent design because, just a couple months before we collected this data, that intelligent design was all the rage in the press, right? So I thought that for sure it was either going to be abortion, religion, or intelligent design, but it turned out to be George Bush. But I guess in a way, George Bush kind of embodies all 3 of those issues, right? So perhaps that's why he is the most controversial president that we do have. So anyways, if you look at the determinants of conflict from that model that we constructed, there are some interesting aspects of this model that we found surprising. So some aspects are not surprising, like, for example, the number of revision increases its conflict. Well, that's kind of, again, no causal effect that I'm trying to draw here. I'm just saying correlations, right? So what's surprising is things like, for example, the number of unique editors in the talk page actually decreases conflict. That's kind of strange, right? Another thing that's really strange that we found was, again, unique editors to an article also decreases conflict. Anonymous edits to the talk page increase conflict. That is, more people who are kind of starting flame wars, this is at least our hypothesis, more people that are going to start flame wars without identifying themselves seems to increase the conflict there is on that particular topic. But the surprising part is that the corresponding anonymous edits to the articles actually decrease conflict. Seems to suggest that the number of unique voices that are added to the article seems to decrease conflict. And so there are sort of explanations that you can use to figure out what these determinants of conflicts are, but certainly, without sort of thinking through or really identifying why these correlations exist, it's not clear to us, why we found these kinds of determinants of conflict. So this is kind of the surprising part.
You've got revisions on the article increases, anonymous edits. What's the difference between?
Oh, anonymous edits are edits that people have not marked their name.
And revisions are?
Revisions just are all of them, whether they're anonymous or not. So one of the things I'm here about is that we have found things like that, but we don't really know the answer, why these determinants worked out the way they do. This is just one of the things about machine learning. You just get spit out of these things, and then you have to try and find answers for them. Another thing that we did was, okay, you might say, well, you apply this model to all the articles that have been tagged. What about all the articles that didn't get tagged that's controversial? Maybe there are controversial articles that are out there that hasn't been identified as such, and they really should be. So what we did was we picked untagged articles that have more than 100 edits, and then we ran through the model that we just created through SVM, and then sampled a range of these predicted conflict scores, and then we send them out as surveys to Wikipedian administrators to validate to see whether our predictions are anywhere close to what Wikipedians would have predicted on the amount of controversy that's on these articles. And it turns out that by Spearman's rank correlation, we do get fairly good correlated predicted score. So this is sort of a little step in validation that this model seems to actually embody what people really mean by conflict at the article level. Okay. So a quick summary of this section is that Wikipedia appears to be this new learning culture on the web where people really talk to each other, and they have these interaction patterns that seem to evolve these knowledge structures. Okay. And that these patterns can either encourage conversation or they can encourage direct contribution. And so, like, for example, the thing that we talked about, the anonymous edits, Wikipedia at the very beginning had this design choice of whether to allow anonymous edits. In fact, the German Wikipedia is right now discussing, maybe they've already determined, I forgot, but they were discussing whether to allow anonymous edits. And this is a design point that has actually it appears to us from the research that we have here, that actually seems to have drastic effect on what might actually happen, the kind of interaction that you might have in these systems, in these wiki systems. So our work here is really to try and find these conflicting patterns and understand them, and maybe start understanding how to design for these kinds of systems in the future. Okay, so I want to go to the second bit of this, which is entitled Power of the Few versus Wisdom of the Crowd. And this is joint work with Nick Couture, Banwan Su, Brian Pendleton, and Todd Mikovits. Okay. So there's been this interesting controversy about the power. Where does it really lie in Wikipedia? Jimmy Wales in December 2004, and he's been actually been going around to these high power conferences like JAL and TED and things like that, talking about his view on how Wikipedia had really evolved. And one of the things that he said that's somewhat controversial is that it appears to him, at least at that time, 2.5% of the users are making half the edits in Wikipedia. And so he said, well, I should really just design the mechanism for that 2.5% of the user of my population, as opposed to designing for the other 97.5% of the user. Well, that's a pretty drastic statement to make. You're saying you're going to ignore 97.5% of your user population. Then Aaron Schwartz, at the end of last summer, who's a fairly well-known blogger, wrote something that got splash-dotted. He actually went and studied a few Wikipedia articles, and then analyzed the content, all the edits that happened in between, and he posited that actually the novice users appears to be actually creating much of the text on Wikipedia. So all of a sudden there was this controversy about, well, is it really the novice users that are creating much of the text, or is it really the elite users who you should really be designing for? Okay, who really writes Wikipedia? Is it the elite users on the one hand, power of the few, or is it wisdom of the crowd, really a bunch of novice users who are joining in and actually creating this content? And who should we design this tool for?
What does it mean to be designing for that segment?
So you might say things like, for example, for the elite users, you might give them really powerful tools for editing or kicking people off or stopping flame wars or whatever. If you know that the power really exists within a very small group of people, you give them very powerful tools. But if you knew that most of the novice users were actually writing the content, then, well, forcing them to use LaTeX to create equations is kind of a difficult thing for them to learn, for example. So you might want to design tools that are a little easier for them to create content, right? So that's what I mean by you might change the direction of the design of the system depending on who really writes Wikipedia. That make sense? Okay, so here's the first graph that we kind of looked at and says, well, it turns out that they're kind of potentially both right. At the end of 2004, indeed, all the administrators in the system appears to be making nearly half of all the edits in Wikipedia. But that has not been true since then. The administrators are making something like maybe less than 10% of the edits at this point in July 2006. So there appears to be this rise and fall of the elite users in the system. So administrator, by the way, is a status that you can achieve in Wikipedia if you've been editing for a while. Yeah.
That's because the profile of the user changed, the number of administrators as
That's a very good.
Or because of the volume.
Yeah, I'm gonna dig to the bottom of that. Yeah, was there
any studies done to correlate something like this with the types of content found in Wikipedia? I would assume the first couple of articles would be very basic, and eventually they would get more and more obscure. And I'm wondering if that maybe has any.
Those are both very, very good questions. And unfortunately, we haven't gotten to the bottom of those, but we do have answer to some of that. I do believe the fundamental mechanism that's happening here is probably something about knowledge specialization. 2.5% of people can only know about so much before they run out of things like knowing about, food. Yeah, for example. Or what's that specific mystery that happened in Lost episode number 24, scene 1, right? Only a few people in the world really knows that kind of information. So I think it has something to do with knowledge specialization, but one of the things that we wanted to do with this research was try and figure out what's at the bottom of this. Okay, so yeah.
Do you have a normalized version of that graph, the number of edits rather than the percentage of edits, because surely that's changed a lot over time?
Normalized by, you mean by?
You've got percent of edits, what about raw number of edits?
Oh, raw number. Yeah, we do have those graphs as well. Some of those I've cut out this talk in order to make it fit in 10 minutes of this part of it. But I can certainly show you those graphs or give you the paper to preprint if you're interested in looking at this.
Qualitatively what it looks like compared to this.
Yeah, what's the shape?
Definitely a exponential for each one of these. So I might actually, do I have one of those graphs in here? It's something like this. This is more or less what you're asking for, right? So there's a lot of lines on this graph. You only need to more or less pay attention to two of them. The red one, which is the novice user that have only made 100 edits or less, and you can see that it kind of has this curve kind of like goes like that. And then the blue one, which is users who have made 10,000 edits or more, and it kind of also goes like that, but much less so.
And when you say edit, you're including both the spelling correction and
Including everything, and I'll get to your question about the amount of edit a little bit because
work that's wrapped in.
yeah, that's kind of a tough question. So I'll try and get to a little bit of that. So it turns out that as a percentage of total edits, whether you do it by this administrative measure where you say whether someone is an administrator or not, or you do the data-driven approach of the analysis where you do this social stratification based upon the number of edits they've made from less than 100 to 10,000 or more, you also see the same effect. So it's not a status label that's being attached. It really, truly, this effect is in the data, right? So, so novice users from these graphs appears to be sharing a larger and larger role. But the question is, why is this really happening? One of the things that we hypothesized was maybe spam bot fighting has gotten better. And so administrators or these really high-power users are not spending as much time on dealing with these spams, and therefore their corresponding contribution. This kind of relates to the question that you're asking. If they're just spending time fixing spelling errors or something like that, maybe as the quality gets better and the number of spam gets lower, therefore they're not spending as much edits on those things, and therefore the contribution kind of drops. Well, that turns out not to be the case. You can actually measure bot activity on Wikipedia fairly easily, and it turns out that no, the bots haven't really gotten any better. They're just been doing the same amount of work ever since. So the guess of your guess earlier about maybe it's just some sort of knowledge specialization thing that's happening appears to us to be the correct answer. One of the things that is evidence for this, we don't have a direct evidence for it yet, is population growth is very different in Wikipedia. So again, you only need to pay attention really to two of these lines. Red one, which is novice users, and the deep blue one, which is the 10,000 edits or more, what we are calling the elite users. You can see that, by the way, the y-axis is exponential, right? So what you're really looking at is the slope of these lines. And you can see that the slope for the high-power users versus the novice users are different. Another way to look at this is by the total population shift that's happening in Wikipedia. In other words, each one of these one slice in moment in time here is a pie chart that tells you the population in Wikipedia. And you can see, again, there's this, as just pure population, elite users are comprising a much smaller part of the total social pie than novice users. And that seems to be driving this effect. And so we're kind of calling this effect the rise of the bourgeoisie because there appears to be that at the beginning, what you need is a small group of people who are really dedicated and really spending a lot of time with the system. And then afterwards, you kind of need this rise of the bourgeoisie to sort of take over and really push the rest of the content forward. But that still really doesn't quite answer the question of who really write the actual content, which is what Bill was just pointing to. So, you know, maybe the edits are not a very good measure because they could just be fixing little spelling errors, or they could be creating a lot of content, or they're actually removing content, perhaps even. Aaron Schwartz says it's the novice users that are actually writing the content. Jimmy Wells says it's actually the elite user. So who's right? So what we did was we took 30 machines and and computed the differences between all 58 million revisions that are on Wikipedia using a distributed computing architecture called Hadoop, which is, I guess, in some ways similar to the MapReduce system you guys have here. And then we looked at what was going on here. So as a proportion of the words that are actually changed by administrators, again, we saw the same thing, that proportion actually has this rise and fall in the system. But what's more perplexing is actually this graph. And this is the graph of showing the different classes of users in Wikipedia and their ratio of words added to the words that are removed per revision. Okay? In case you can't quite do the math in your head, I did this little trick here. This line above 1, anything above 1, that means that class of user have added more words than they have removed words. Anything that's below that line means those groups of users have removed more words than they have added words. Okay? So the novice users are removing more words than they're actually adding words, and everyone else appears to be adding words. So, but yet, the novice users are also the group of people who are doing the most amount of edits by a large proportion earlier,
Are you counting
right?
reverts in here? If a novice blanks a page and somebody restores it, you count that restoration as adding words?
Yes, we do all. We do the raw diff between the revisions. Yes. Yep. So, what's really going on here? Well, unfortunately, I don't really have an answer for you. This is still a little bit of a mystery to us as well. This is where the summer ended and the interns left, and then we haven't had time to go back and really answer this question yet. But this is a very interesting phenomenon that appears to be happening. So the summary for this little section here is that it appears that you could have some basic understanding of the patterns for how to bootstrap a learning culture like a Wikipedia, right? It appears to us from this analysis that you need a set of very dedicated elite users, at least it seems to me, in the beginning. And then at some point, you have this rise of the bourgeoisie that needs to happen in order to carry this system forward. Now, you might say, well, you only study Wikipedia, so how can you say that this is going to be true generally for all social systems out there? Well, the part I didn't tell you about is that we also study Delicious. And in Delicious, it is exactly the same phenomenon appears to be happening. So there appears to be the same thing going on in Delicious, where a very small group of users was really dedicated in using the system for a long time. And then later on, there was this mass of people that was joining it that really carried the system forward. But this more or less still has some open questions about the pattern of contribution versus group of users that are on there, and we don't have all the answers here. This is just a characterization study, right? We're not really trying to say too much here.
Would you say that first point is a generally accepted
point in general?
because the observation recently about Dig sort of delisting their top, not delisting, but de-emphasizing their top contributors in a certain way is really.
That's a very interesting point that you. Yeah, that's a very interesting point that Bill, you just brought up, because people are kind of creating these systems blindly and just trying to see what would happen without really measuring what was really going on. And like you said, in Dig, there appears to be de-emphasizing these elite users at this point, because so much of the bourgeoisie are now joining in as part of the parade. So now all of a sudden it seems like the algorithm that you had used to bootstrap the system in the beginning is not the same algorithm that you need in order to keep it going later on. And so it has a real design implication in terms of the kind of algorithm that you might design for this kind of vote counting system, or Wikipedia systems, or all these kinds of collaborative systems as well. Yeah. So how am I doing on time?
Oh, well, you're scheduled to end at 1, and it's like 8 minutes to 1.
Okay. Well, I'm going to try and breeze through this part of it faster on analysis of tagging system. And this is joint work with Todd Mikovits. And I really want to show you this because I think this might also apply to some work that you guys might be interested in doing. So the problem that we're interested in looking at in this little part here is, how do we evaluate a tagging system? And what I really mean by that is, given a tagging vocabulary, how effective it is actually in describing a set of URL. That was this thing that we were interested in looking at. The approach that we took to attack this problem is, again, the 2-key method. Let's crawl the whole damn thing. we crawled the entire delicious bookmark set, and the way we did that was we had 30 machines, and we wrote a little screen scraper, and we had it going all at the same time, making a request everywhere from 5 to 10 seconds. Random, and crawled it for like a month and a half or something like that. And then we started using some information theory to look at this problem. How many of you have taken information theory class in college? So some set of you. I didn't. So I had to get myself up on this really quickly over the summer. I took a little bit of this in statistics class, obviously, but I didn't really truly deeply understand it. But I want to explain to you very quickly what entropy means. Entropy is the measure of the uncertainty. Just remember that. Entropy is the measure of the uncertainty. It measures the uncertainty about a particular event associated with the probability distribution. That's what entropy means. So the easy way that sometimes people have explained this is through a saw experiment. If you're drawing color balls out of a box, if you have a bunch of different colors in there, and there's no single color that predominates the distribution, then the next ball that you draw out, you never know what color it might be. It's completely random. You have no idea. That's when entropy is maximum. You have maximum uncertainty. Okay, does that make sense? So if the box only contains black balls, every time you reach in and grab out is another black ball, then you know almost for certain that the next time you're going to grab, you're going to get a black ball, and that's when entropy is the lowest, and that's when it's minimum. Okay, it has very low uncertainty about the next color ball that you're going to get. That's the way to think about what entropy really measures. So it turns out that entropy can increase only in 2 situations. One is the total number of events increases. The other possibility is that the probability distribution becomes more uniform. Okay, so this is just sort of only equation I show in this talk. I could show more, but this is the only one I'm going to show. So here is the entropy of tags showing the saturation in tag usage. So what's happening, this is January 1st, 2004, that's when Delicious really started, more or less, beginning of time, so to speak. And you can see that the entropy, that is the uncertainty that you're going to see the next tag, increases, and then it finally just kind of plateaus. Okay. So what that seems to suggest is that the encoding of the tag was getting more and more uncertain, and at some point, the encoding of those tags for the sources that are in Delicious just kind of stay at the same level. People have kind of discovered all the tags that they probably need to describe the information sources out there. And it seems to suggest that the way people think about tagging is stabilizing in terms of the tag usage. There's this saturation effect that's happening. Another way that you can actually look at this data is through conditional entropy, which is measuring how much entropy or uncertainty is still in a random variable has remaining if you have learned completely the value of a second variable. So how does that apply in this case is that you can actually see the amount of uncertainty that is still in the document if you knew all the information there is to know about the tags that are already in the system, right? So what this really says is if you know all the tags that are already in the system, how much uncertainty do you still have in the system about the document that you're going to see? Does that make sense? Okay. So that's increasing. The amount of uncertainty about the document that you're going to see in the system is increasing despite the fact that you already know what the tag is already in the system. So what that seems to suggest is that if you're simply using tags to browse through this space of linkages between tags and documents, it's getting harder and harder for you to swim through this space because all the uncertainty that's in the system is actually still increasing, even though the tags are stabilizing. Does that make sense? Okay. Another way to explain this, you might think about, is that how are people sort of coping with this? And there's a connection to search that I'll talk about in a second. But the average number of tags per bookmark has gone from 1.8 since January 1st of 2004 to 2.8 more recently, right? So what that is saying is that people are coping with the fact that words are losing their ability to specify documents by adding more tags so that they can be more specific about what's actually in the document. Does that make sense? And it's the same thing that has been happening to the user behavior in search. People have gone from originally 1.8 average in about 2001 or so, into 2004, 2.8 query words per search, to about, what, 3.4 and probably a little bit more now, right? And the reason is it's an evolutionary response to the fact that the document is getting bigger and bigger. In order to really specify the information that you need more and more words to actually specify that particular piece of information that you need. Right? So that's kind of the point of what I'm trying to say about this analysis.
So could this also be that more users are entering the same bookmarks and then are trying to personally tag them for their own use? Do you know what I mean?
You're
So
asking,
you
right?
increase the user base
Uh-huh.
and sort of the world of, that people are hitting on the same bookmarks in the system. And so those people are adding
More and more tags.
more personalized tags for their own.
More and more personalized tags.
Well,
Yeah.
tags that come from their own,
Right. Their personal experience or whatever. Right. So they might.
their own ontology.
For example, someone might start tagging the thing to read 2168. Whatever that means. Right. That's an interesting point. One of the things that we didn't do is really try and understand what's the relationship between the group usage of social tagging versus personal usages of person tagging. That's kind of an open question that needs to be examined from a research point of view. I don't really have good answers for you, unfortunately, on that. Yeah.
There's another measure that could be interesting, and that is the level of information you get per tag. That is the reduction in uncertainty. So it's possible that the average number of tags remain the same, but the tags become better in terms that they are more informative. Like they partition the space of documents in a better way.
So you're in a way that you're asking about a measure called mutual information.
Exactly.
Yeah, and we actually did measure that, and it turns out that if you look, I don't have this slide in this slide set, but it actually increases at the beginning, and it's been dropping ever since.
So that's the average overall tags, or?
Average over all the data that we have, all tags, all documents.
So this means that people add more tags, but the tags that they add are not that good. So they
That-
start with like very good tags, but then they run out of good
That's right.
keywords.
And the way that they're responding to that is by adding more number of tags per bookmark to increase what they really mean by that content. Does that make sense? Yeah. You got it, exactly. Yeah. So, so the summary for that little section there is really that entropy appears to be a way to think about as a measure for the social tagging system. It appears to be a good way to measure it. And that as a map, it seems like social tagging are losing their ability to guide user efficiently, and the way that users are responding to it is by increasing the number of tags they have per bookmark. And that has, again, design implications for the kind of social tagging system we might want to build in the future. So this is kind of a framework for thinking about it and analyzing it. So I have one more slide. So in conclusion, I took exactly 1 minute, 1 hour according to my clock here. What I tried to do in this talk is to define and outline this area of research that we are calling augmented social cognition. What we're trying to do is to understand the emerging behavior in social software and how to understand how to enable these kinds of social foraging, searching, and sense-making that people are doing around these systems. Trying to understand the conflict, the coordination cost of various kinds of design choices that you might make in these systems. And we're arguing that the first step to try and understand this area is to get a big paper and pencil and try and start characterizing these behavioral data. And we've shown 3 examples of that: conflict and coordination in Wikipedia, power shifts in Wikipedia, and the tag usefulness of delicious. And it appears that there are metrics that you can use to try and attach these problems. An understanding of this area is likely going to need a multidisciplinary approach. And so this is kind of a little bit of a call to arms of all the researchers to who are interested in this area, perhaps to go and understand this area a little bit better. So again, I'm always amazed that people are willing to pay attention to me talking. So thank you very much for giving me an hour of your time.
Well, thank you.
Thank you.